Hey there, fellow time travelers. Today, we're diving into the fascinating world of time science. Did you know that the Earth isn't exactly round, but flattened at the poles? It's true. This means that if you were to travel from the North Pole to the equator and back, you'd cover a longer distance than if you went straight. In fact, a trip around the equator is 43,230 miles, while a trip from pole to pole and back is only 24,902 miles. So, if you manage to travel at the speed of light, which is 186,000 miles per second, you could potentially experience time dilation. But wait, there's more. The distance between 2 points also depends on their altitude. Imagine being on top of Mount Everest, even if it's only 5 miles away from your starting point at sea level. It still takes longer to get there because you have to go up. This means that altitude can affect your travel duration and potentially cause time dilation as well. Now, let's delve deeper into the concept of time dilation, shall we? According to Einstein's theory of relativity, time isn't a constant, it bends and sways depending on speed and gravity. This means that the higher your altitude or the faster you travel, the more time shifts for you compared to someone else who's, say, peacefully sipping tea at sea level. For instance, if you were to journey up to the summit of Everest, not only are you traveling through space, but you're also experiencing a different gravitational pull than someone at sea level. This interplay between altitude and speed can create fascinating paradoxes. Consider two twins. One stays on Earth while the other takes a brief jaunt to a nearby planet at near light speed. When the traveling twin returns, they might discover that their earthly counterpart has aged significantly more. This isn't mere science fiction, it's a consequence of how time unfolds under different conditions. Furthermore, let's not forget the implications of our beautiful planet's irregular shape. Earth isn't a perfect sphere, it's an oblate spheroid, meaning it bulges at the equator. This bulge slightly alters the distances traversed depending on where you are. Spanning the distance of the equator, you're subject to a different gravitational field compared to standing on the poles. Some calculations suggest that the time you experience could vary even just by walking around your neighborhood, depending on how high you are or how fast you go. So there you have it, folks, just a few examples of how time science can be influenced by our planet's unique shape and geography. Next time you embark on an adventure, keep these fascinating facts in mind. And as always, thank you for joining me on this exciting journey into the world of time science. If you enjoyed this video, don't forget to hit that like button and subscribe for more content like this. Until next time, happy travels!